All right, welcome back, Patriots. This is Mr. Love, aka the Math Patriot, giving you another lesson in the exciting world of high school geometry. Today we're on Unit 1, Lesson 2, line segments, distance, and midpoints. Last class period, we talked a lot about what lines are and what planes are, what points are, our three undefined terms of geometry. You should be familiar with that. If not, go back and take a look at that first video in this playlist. All right. So, line segments, distance, and midpoints. What we're worried about today is taking our lines that we originally had that were infinite in both directions, and we're going to start chopping it off and making it shorter. We're going to start worrying about sections of lines. Okay, that's what a segment is. Now, as far as what an actual segment looks like, it is the measurable part of a line consisting of 2 points, which are called the endpoints, and all of the points in between them. Now, this section right here about it being measurable, that is very, very important because every segment has a measure. Okay? There's also a very big difference between a segment and its measure. Just like there's a difference between you and your height. Okay? If I asked you who Bob was, that's a person standing over in the corner. If I ask you how tall Bob is, that's like 5'9" or whatever, okay? We'll get into the measure quite a bit later on. Now, as far as what we call them, we name them based on the two endpoints. So we name this one AB with the line segment symbol. Notice the symbol change. There are no longer the two arrows on the symbol. It is just a straight little dash, pronounced segment AB. Also, we only ever name a segment after its endpoints. So if there was a third point C here, we could not name it AC. It has to be AB. That being said, there is one other appropriate name for this line. Anybody want to hazard a guess? Yes, but not just BA. Not line BA. Segment BA. Segment BA. Okay? Only two possible names for this line segment. Okay? We're not going to get into the small italicized, small script letters. That's only for full lines. Okay? Any questions so far? All right. Measures. The measure of segment AB is written as AB with no symbols above it, okay? So if I talk about this thing right here, segment AB with a bar over it, I'm talking about that geometric construct, the line segment, 2 points with all the points in between them. If I talk about this thing with no symbol above it, that is the measure, which would be like 6 inches. Okay, it's a distance. Yes, ma'am.
Is this on our paper?
Not everything is on the paper. No, measure is not.
Okay. Do you want us to put it on the back?
Yeah, if you want to put things on the back, that's fine. Usually the things that aren't on there are the simpler ones that you don't have to. It's just something I want to bring up, but it's not a big deal. So like last time, the undefined versus defined, that wasn't the biggest thing in the world, so I didn't put it on the paper. Okay. All right, also everybody out there in YouTube land, the reason that I am pausing for sections like this is for my live class to write, and I'm just waiting for the pencils to stop moving. Sorry about the delay. Okay, moving forward. Betweenness. All right, when we start talking about between, we're talking about something that lies exactly on the straight line between 2 points. Here, M is between P and Q, and if it was slightly out of the way, like if I had point N right here, N is not between P and Q because you would have to follow 2 different paths to get there. Now, this is... We kind of talk about cities being one between the other. Like we talk about Dallas, Fort Worth, Austin, and San Antonio. And we talk about Austin being between Dallas and San Antonio. Well, I mean, I've never actually gone out and done this, but I'm pretty sure I-35 follows a slightly winding path between them. And the only way Well, and we say Austin is between them because it's on the road. So in this idea, yes, it's on the road in between them, but geometrically, in order for it to be between them, if you took an exact straight line, and Austin's not directly on that line, then no, Austin is not between them, okay? So it's got to be directly on that straight line, all right? Now, also in geometry, as you go through, you're going to be expected to generate your own equations based on a picture or a diagram that you're seeing. So anytime that 3 points are on the same line or segment, we're going to expect you to be able to come up with an equation similar to this one. That basically the left side plus the right side equals the whole thing. Okay, now, let's simple numbers here. If this is, well, start over with an actual pen instead of a highlighter. If this one is 4, if PM is 4 and MQ is 2, then the full distance from P to Q, this whole thing, is 6. And every now and then, well, on many problems, you'll be asked to actually generate the equation PM plus MQ equals QP, or the corresponding version for whatever the points are on that problem. Okay, any questions? All right, here's one that's just like that. Find BC, and notice no symbol above it means the distance or the measure of segment BC. So to start off with, we're going to be writing an equation. So the measure of AB, forgive me, that should have been a plus. The measure of BC equals the measure from A to C. Left plus right equals whole. Now we start substituting in. Okay, AB is 2 3/4 plus the distance from B to C, which we don't know, equals AC, which is 6. Now, notice that right here, this BC. In algebra, we saw only single variable or single letter variables, all lowercase. You'd have X, you'd have Y, you'd have Z, that sort of stuff. In geometry, it's okay for us to use our notation as a variable. So here, BC, I don't need to convert that to an X. I can just use the measure of BC as a variable itself and let that cascade all the way down to the problem. It makes it easier for us to do that because it helps us do substitutions and things as the problems get more complex. Okay, now we're just going to solve that. Subtract on both sides. 6 minus 2 3/4. So BC is, yes, 3 1/4. And let's make sure we throw our inches on there. As far as units go, as long as every single unit in the problem is the same, so we got 6 inches and 2 3/4 inches. As you're writing this stuff, I don't require you to carry the inches on every single one. However, as you get into some of your more upper level classes, physics, some of the chemistries, that sort of stuff, also in calculus and statistics, it's important to actually write your units in. Just make sure you check your units at the beginning. If every single thing's in the same units, I don't expect you to write it. If it's not in the same units, you might want to write your units in there. That way you're able to know when you have to do a unit conversion, right? Or convert all the units to the same thing at the beginning. All right, any questions? All right. Example 2, find X and AC. Now, let's go ahead and write our equation here. AB plus BC is equal to AC. Left plus right equals whole. And now let's substitute in. AB is X plus BC is 2X equals AC is 2X plus 5. All right, simplify like terms or combine like terms on the left gives me 3X equals 2X plus 5. Now what? Thank you. Subtract 2X on both sides gives me X equals 5. And I got x. Am I done?
No.
No, because I've only answered half the problem. It's asking me for both x and the distance from A to C. So let's plug it into the right place. AC was that one I highlighted in orange. 2x plus 5 equals AC. So that's 2 times 5 plus 5, which gives me 15 equals AC. And there are my two answers. Notice no units on this one. We got naked numbers.
I was just raising my hands in glee for getting it correct.
All right. Any questions on example 2? All right. Number 3, find the value of x and st if t is between s and u. So that verbiage there, t is between s and u, tells me that I've got 3 points. Now I just got to decide which ones are the endpoints. What do you think? Which two will end up on the beginning, or which ones will be the end? Which one's in the middle? Okay, s and u. Yeah, so t is between them. So yeah, t is going to be between. So we got s and u. Now, st is 7x. su, the full distance, is 45. And then tu is 5x minus 3. All right, now for solving that one. Very similar to last time, right? Anybody want to give it a shot? Anybody want the golden tablet? Okay, it's more silver than anything else. All right, just so I know, whenever I hand this off to a student, I'm going to change the color, so she's going to be in orange. Careful of just copying down directly what's off the board. Try it on your own first, and then we'll see what we come up with. All right, go ahead. All right, st plus tu equals su. Very good. Awesome. All right, working our way down. X equals 4. Very good. Are we done?
No.
Because it's asking us for the value of x and st. So now it's going to go ahead and plug it back in and give me 7 times 4 is 28. Awesome. All right. Thank you very much, Brooklyn. Also, I want to go ahead and point something out. I love the way that she did this. Notice how she's breadcrumbing her way through. Notice how the all of the work is nice and organized. Her equal marks are roughly lining up. All these little things that you see your teachers doing, guys, it's not an accident. Most of our algebra teachers, most of our 8th grade math teachers, anytime they're doing equations, you'll see their equal marks line up. You'll see them write these little breadcrumbs through there. It's not because we're doing something remedial for our students. It's because these are just good habits to get into to make your work more organized. Okay? So overall, very good. Any questions on this one? All right, moving on. Okay, congruent. I don't believe... Yeah, it is. Okay. It is on the sheet, on the notes. Congruent, identical in size and shape. You've heard that same size, same shape before. I want to go ahead and point this out about your notation, though. Whenever I have these two horizontal lines directly above each other, what does that mean? Okay, when I just wrote in orange on the board, what's it mean? We have two horizontal lines above each other. What's that symbol?
It means it's different from other sides. So it means it's longer, either inches or centimeters.
Come on. Yeah, it's the equal sign. I know, they're slightly different.
Oh.
Okay, I know, I messed you up. They're slightly different sizes. I'm sorry. It's the equal sign. Okay, that means equal. Okay, now, what about this symbol? The little squiggle. First off, anybody know what that symbol is actually called, like on a keyboard? It's called a tilde, T-I-L-D-E. Okay, but in math, you know what it means?
Well, doesn't it mean like you have like a point for
No, that is like, okay, what you're saying is like 3.3. That's the repeat bar. It's not a squiggle like that. It's just a straight line bar above it. Okay. You said roughly about the same. Okay. That could be there. It literally, mathematically means similar. Similar in geometry is same shape but different size. Okay. Think of like equilateral triangles. Same shape but different sizes. Those are similar. Okay. Now, if I combine those two symbols together, I say that it is similar, same shape, different size, yet equal at the same time, same size, same shape. The two symbols work together. Okay. So we'll be using those, all three of those symbols throughout the year. Also keep in mind that numbers are equal, shapes are congruent. And you'll see that notation difference play out as we go through here. Okay. Okay, congruent segments are segments that have the same measure or length. We indicate that with our little hash marks. You can have a 1 mark, a 2 mark, a 3 mark, a 4 mark. I've never seen anything bigger than 4. And so also keep in mind, whenever I put those little hash marks on there, that only extends between the 2 points it's directly between. So for example, if this guy had gone out further and there was a number or a third point Z, the hash mark here only applies to segment XY and makes no indication whatsoever about what happens between Y and Z. Okay, it's only from X to Z. Now, here's where that notation comes in. AB, or segment AB, is congruent to segment AY, which is what we have down here at the bottom. However, AB is equal to XY because segment AB is a geometric figure. It's a segment, whereas AB is a distance or a number. Figures are congruent, numbers are equal. All right. So are segments XY and YZ congruent? Now, oops, I didn't mean to do that in blue. Oh well. Okay, we'll make it work. XY is my left-hand side here, and YZ is the bottom side. Now notice I have my congruent marks over here for XY and for XZ. The way I'm going to approach this is, since both these two sides that are marked have X's in them, I've got to solve for X. I'll plug it in and test to see if they're equal. However, I don't know exactly what X is yet, but since these two sides are equal to each other, I can use those two to find out what X is. I can say that XY is equal to XZ. And now plug it in. 3x plus 5 equals 5x minus 1. I hope I don't blow anybody's mind here by doing 2 steps at once. I'm going to subtract 3x on both sides, gives me 2x. Add 1 to both sides gives me 6. Then divide both sides by 2, and that gives me x equals 3. Notice that doesn't help me answer the question at all directly, okay? I just finding x, don't get in the habit of, I found x, so I'm done. Answer the question that's being asked. Let's plug it in and find xy. Xy is 3 times 3 plus 5, which is 9 plus 5. Xy is 14. YZ is 9 times 3 over 2, which is 27 divided by 2, 13.5. So are segments x, y, and yz congruent? No, because they do not have the same measure. By the way that we write that, x, y, and y, z, we're going to just put a slash through it to say not congruent. All right, any questions? Okay. Now, finding distance on a number line. We're going to be just taking the values of x1 and x2. Now, we're talking about number lines also. We're talking like old school first, second grade number lines here, okay? We're just going to take it, subtract them, and then take the absolute value. Taking the absolute value forces us to have a positive number. Distances are always positive, okay? So that's why it doesn't matter if I put x1 or x2 first. We're going to get the same thing because we're taking absolute value at the end. All right, let's do all three of these rather quickly. BD, again, it doesn't matter which one you do first. B is at -7. Minus D is -1. All right, what's -7 minus -1? Is -6, so our answer is 6. Distance from B to D is 6. And we can always verify that if we wanted to. 1, 2, 3, 4, 5, 6. Yay. Remember doing that in elementary school?
Yeah.
What'd y'all have? Did y'all have bunnies hopping on the line?
Yes.
What? Any other cutesy ones we did? Besides the bunny hop? That's all y'all did?
I don't remember doing it, but I don't remember listening to them when I just counted.
Okay. All right. So AF is, A is where? -9. Minus F is 3. Which gives us absolute value of -12, which is 12. You get the idea. Just to make things go along faster, I'm going to skip BG. By the way, you're going to see me writing skip on these when I actually skip them. That way, if you're actually going through and checking the notes online out of my Google Classroom, you know I skipped it for a reason. And that way you're not worried about what needs to be filled in there. Okay. Distance formula on the coordinate plane. x2 minus x1, square root of x2 minus x1 squared plus y2 minus y1 squared. I want to go ahead and point this out about number lines here, or sorry, not number lines, but about the coordinate plane. When you have the coordinate plane, notice that if I was to find these two distances, the horizontal and the vertical distance, I could do the Pythagorean theorem to get the distance from A to B. Now, when I take this x2 minus x1, well, here, x2 minus x1, that's just, x2 minus x1, that's just this distance here. y2 is here, y1 is there, y2 minus y1 is just that distance there. All this is a conversion of the Pythagorean theorem to work on a coordinate plane, and it will always work even when you don't have it drawn. So there will be places where I will just jump in and out of Pythagorean theorem versus distance formula, depending on what's presented to me on the page. Okay? So, here we go. Find the distance between the 2 points. So, MN, the distance between M and N, is the square root of, notice I'm going to get my whole thing set up, scaffold the whole problem, so whenever I plug it in, I make fewer mistakes. Okay, x2 minus x1. x2 is 9, x1 is 1, because we got x1, y1, x2, y2. And then y2 minus y1 is 13 minus negative 2. Simplifying down gives me 8 squared plus 13 plus 2 is 15 squared. Eight squared is 64 plus 15 squared is 225. And then 64 plus 225 is 289. And I believe that's a perfect square. Because if I type it in the calculator and check, I believe it is. I think it's 17.
Yep.
All right, yeah. All right. If it's a nice perfect square, go ahead and do it. If not, we're going to be reducing radicals just like you did way back. Well, I guess it wasn't way back. It was towards the end of Algebra 1. All right. We're going to start skipping some of these. Do y'all think I need a lot of examples of that? Or do y'all think y'all are good? Okay, so I'm going to skip number 7. Example 8. This is one where I said I'm just going to jump in and out of Pythagorean theorem. I'm going to go ahead and just find my 2 pieces here because I can see that this vertical distance is 2 and this horizontal distance is 1, 2, 3, 4. So I'm just going to do a squared plus b squared equals c squared. 2 squared plus 4 squared equals c squared. 2 squared is 4. 4 squared is 16 equals c squared. 20 is c squared. Take the square root of both sides, gives me square root of 20 is equal to c. And this is where we're going to do our reduced radical. All right, remember we're looking for a perfect square that evenly divides into 20. And so that's 4 times 5, 4 being our perfect square. Square root of 4 is 2, so that's 2 root 5 is equal to c. And because it's asking for distance between points A and M, AM equals 2 root 5. All right. Midpoint. When we talk about midpoint of a line or of a segment, we're talking about it is exactly in the middle. It exactly splits the distance. So if the distance from A to B is 10, then each piece is 5. So anytime you see midpoint, you're going to have this base equation that comes through. The left equals the right. The top equals the bottom. One side equals the other side. And also the 2 segments are congruent. So segment AM is congruent to segment MB. Now, when we get to the back side of your sheet, of your example sheet, there's a lot of examples there, and they're all pretty repetitive. We're not going to do every single one. We're going to skip around quite a bit. Also, because class is over pretty soon, so we're going to skip through those. All right, a segment bisector is anything, point, line, segment, or plane that intersects a segment at its midpoint. So you'll notice here that I've got segment PQ here has exactly its midpoint at M. So point M is a bisector of PQ, of segment PQ. Also, segment JM is a bisector of PQ because it cuts it exactly in half, intersects at the midpoint. Also KM, and also plane A, because plane A crosses it exactly at the midpoint. Okay, anything that cuts it in half is the bisector. By the way, bisector literally means cut in two. Bi is the prefix for two, sect is to cut, so to cut in two. All right, any questions on that? All right. Midpoint formula on a number line. Literally, you just average them. Add the two numbers and divide by how many there are. So in this case, which is just 2. So we jump over here, find the midpoint of AF. So I'm going to use M since it's the midpoint. Okay. A is at -9. F is at 3. So the midpoint is at -9 plus 3 is -6/2, which is at -3. Pretty simple on a number line. Just average the two. All right. I'm going to skip number 10 because this section is one of our easier ones. Also, skip example 11 because we want to get to the midpoint formula on a coordinate plane. Notice that we're doing the exact same thing we did before. We're averaging the x's, but we're also just adding in averaging the y's. So when you look at it graphically, we're essentially saying that we're going to take our vertical distance from y1 to y2 and just average it the same way we did on the number line earlier. We're going to do the exact same thing with our x's, and then the place where those two averages come together is the midpoint. So two separate calculations. You're just doing the exact same thing we did on our number line, but doing it twice. Okay? Here, since we already have a point M, I'm going to call the midpoint point D, just because I need a letter of some kind. So D is located at x1 plus x2 over 2, y1 plus y2 over 2. Notice the comma means they're separate different things. You don't combine everything together. So x1 is 11 plus x2 is -9 all over 2. y1 is -2 plus y2 is 13 all over 2. Now let's just run our math in. 11 plus -9 is +2. Divided by 2 is 1. -2 plus 13 is 11. Divided by 2 is 5.5. So there's my midpoint. 5.5. Don't know why I put that other dot there. Okay. Questions? Easy enough? All right. So here's another one. I'm going to skip this one. Same idea. The wording here is a little bit weird, but it's the same thing. Find the coordinate of the third. Notice the y is the midpoint of x and z. Still the exact same thing you did before. We go to 15. Again, y is the midpoint of xz. Still the same thing we did before. 16, I believe, is the one I want to do. All right. So y is the midpoint. Notice it gives me x and y. So I have the midpoint given to me in the problem. I want to find the third point, which is the other endpoint. So here, y, sorry, let me write this the right way. How do I want to write that? Oh, yeah. xy for the midpoint is equal to x1 plus x2 over 2, y1 plus y2 over 2. Now, when I go to plug them in, notice that y is my midpoint. So y is going to be over here as 12, 9. And then my x is going to go in for the x and y. So when we write this in, here's my x1, y1. So 3 and 7 go here. And then x2, y2 are in their original places. Okay? Only difference here is that our numbers for the midpoint went over by themselves instead of in the calculation. Now, what that's going to give us is essentially two separate calculations, an x calculation and a y calculation. So we're going to have 12, so the x is first, is equal to 3 plus x2 over 2. Okay, just took these guys and put them over there. Now let's solve. 12 times 2 is 24, equals 3 plus x2. And then subtract the 3, 21 equals x2. Do the same thing with the y's. 9 equals 7 plus y2 over 2. Multiply 2 by 2 gives me 18 equals 7 plus y2. Subtract by 7 gives me 11 equals y2. So my coordinates for the midpoint, the endpoint, z, is at x1, which is 21, x2, which is 21, y2 is 11, and there's my third point. That's the most difficult one on this entire thing. Okay, any questions about how I got that? All right, I believe there's one more example, which is 17. And I'm going to skip that one because you guys have got to go to your next class. So that's it for now. Feel free to come and ask me any questions if you have them. And as always, thanks for tuning in and stay patriotic.